The other day, we learned about how to solve absolute value equations algebraically, with the understanding that there's two solutions typically to absolute value equations because there are two places on the number line which are the same distance away from zero. It might be good to take a few minutes and refresh your memory about how to split the absolute value equations into two cases before you solve them algebraically. One of the other things we learned as well was how we can get things called extraneous solutions when we're solving absolute value equations. Extraneous solutions are solutions that you get algebraically, but when checked for their validity, do not make sense and therefore cannot be solutions. We also learned that there are cases where there is no solution to absolute value equations, and those arise when the absolute value is equal to a negative number. Because absolute value cannot be equal to a negative number, sometimes there's no solutions. In this video, what we're going to do is we're going to look at how to solve absolute value equations graphically. We spent some time looking at algebraically. Now it's time to look at how to do it graphically. And to do this, we're going to be using the graphing utility program Desmos to help us solve those absolute value equations. The process is actually quite simple. All you have to do is take an absolute value equation, like 2x, the absolute value of 2x minus 1 equals 5, and split that into two equations, which can be graphed on the Desmos graphing calculator. So if we take the left side, we turn it into the equation y equals the absolute value of 2x minus 1. And on the right-hand side, we turn this into the equation y equals 5. So what we're doing essentially is we're creating two separate equations using the x and y variables, which can then be graphed on the coordinate plane. Let's take a look at what that looks like on Desmos when we graph those two equations. So you'll want to open up your Desmos graphing calculator, and in Desmos, you're going to want to enter those two equations which we just established. Y equals, and there are absolute value symbols on that Desmos calculator. You see it down there on the bottom with an A in between. And then type in 2x minus 1. You'll notice the shape of the graph of an absolute value is shaped like a V. This is true for all absolute value equations. They're shaped like a V. It's called the absolute value family of functions, and their graphs are typically always in this shape. Now, we're going to enter the other side of the equation that we had earlier, y equals 5. Y equals 5. And you'll notice that a second graph pops up. You don't need to worry about those little blank spaces in that equation. You'll see there is a horizontal line at y equals 5. Now, if we examine these two graphs, we'll notice that they intersect, right? Since we're looking for where the absolute value of 2x minus 1 is equal to 5, we're looking for where their graphs are equal. And their graphs are equal at the points of intersection. You'll notice here their points of intersection are at -2, 5 and 3, 5. Since we are solving for x in this equation, we are only concerned with the x values of those two coordinates. So in this case, the solutions to this original equation are x equals let's check them out again, -2, and x equals 3. And there's a space for this on your notes. You can see right here. The solutions to this equation are x equals -2 and x equals 3. The process is quite simple. Again, all you do is split your original absolute value equation into two sides, each of them becoming y equals something. You graph them separately on the coordinate plane using Desmos, and you find the points of intersection, and you state the x values of those points of intersection. Those are the solutions to the absolute value equation. And you might notice that sometimes there are two solutions. Sometimes there's one, right, in the case of those extraneous solutions. And sometimes there are 0 if the two do not intersect at all. This is how you solve an absolute value equation graphically. And now you get to practice.